Hello, everybody from Germany. My name is Ira Dietheim. As Ben already introduced me, I was a computer science teacher for, I think, about 7 years at a secondary school in Braunschweig, and now I'm responsible for teacher education at the University of Oldenburg. I hope you all can understand me quite well because I have quite a bad cold at the moment, so don't be surprised if I make a break to.
Eva, sorry, just to interrupt you briefly. I can hear you very well, but there are a couple of participants who say they cannot hear very well. Maybe just double check the microphone. As I said, I was able to hear you quite well, but if you could just briefly double check that before continuing, that would be appreciated.
Yeah, but I can close my microphone once and open it again, so maybe that helps. So I mute it for a second and then I'm back.
Okay, that sounds good.
Okay, now I'm back.
Yes, just in between, let me just say there are some of you who have joined the webinar, but you haven't joined the audio conference. You need to make sure you join the audio conference, otherwise you won't be able to hear anything, and of course you won't be able to hear me saying this. So I'm going to post this into the chat in a second. Okay, now back over to you, Ira.
Okay, okay, everybody, I hope everything is fine now. As I already said, I'm responsible for teacher education at the University of Oldenburg, and I have quite a bad cold, so maybe I try to speak a bit slowlier than usually. Let me first say that I'm very proud of being part of this MOOC on teacher education for computing. I think this is something we really all need, and it's very special that has not existed before, and I'm very happy to join this course as a lecturer. And I also am very happy to join this course as a participant because I think I can learn a lot as well as you all. So, first, this webinar is about more or less perspectives on teaching computing. It is a bit different than the title, but it has to do with each other. Reflecting on pedagogical approaches cannot be separated from different perspectives that people have on teaching computing, so don't mind the different titles. To start with, what I want you to learn in this webinar is that there are different perspectives on teaching computing, and I hope to give you an insight into how different these perspectives can be, how you can cope with these different perspectives on computing, and I would like to present you not only briefly a few different perspectives, a few approaches to computer science education, but also I would like to introduce you very briefly to a framework that helps to deal with all these different perceptions and perspectives on computing. So this is what I want you to learn, and I hope that you can use it afterwards. When I went through your questions that you stated in the last week as a preparation for this webinar, I was very overwhelmed by the number of participants in this course, and also overwhelmed by pointing at the point of a compulsory subject. I think worldwide it's a very big problem that we all have, or many countries have, that computing is not in that situation that it should be in our point of view. So computing is not only about delivering some kind of knowledge or competencies to students according to a certain curriculum. It always has a political perspective as well. So, but before I get closer into this discussion about compulsory subject or not, please let me lay the land that we talk about at the moment. As you all might have perceived, teachers have various perceptions on their subject. So please take a few. Okay. What is computing in school about? So please take a few seconds or 2 minutes to reflect on your own perception on what is computing in school about. Is it algorithms and computing? Is it computer applications and their use? Is it creation and understanding of computer systems? Is it about fundamental ideas of computer science? Is it about information and its processing? Or is it about ubiquity of information technology in everyday life? Well, if you have to choose one of them, what will it be? So please, Benjamin, start the questionnaire.
Okay, everyone, I'll be starting a questionnaire now. You have a multiple choice question here. Oh, just give me a second. Where you can select one answer, and you'll have about 1 minute to answer this, and then I will share the results with you. So the answer already coming in. We're now 44 on the course. On the webinar, sorry, and there's 30 of you who still haven't replied. That number is dropping rapidly now. What is computing in school about? If you'd have to choose, how would you describe it? That's the question that Ira has asked you. 18 more left to answer.
Some have answered in the chat, I think. They also
yes.
should answer the questionnaire.
Thanks, Ira. Thanks for flagging that up. Yes, if you have posted your message in the chat, please post the answer directly via the questionnaire, via the poll. However, it might be the case if you are connecting from a mobile device, then these polls are sometimes not accessible, depending on what tool or what OS you're using. So. But if you are using a computer, please make sure you answer the question of the poll directly. Now we have 12 participants who have not yet answered. I'll give you another 30 seconds before I'm going to close the poll and share the answers with you. Okay, only 10 people left, 9. So final 10 seconds. Okay.
Oh, great.
Now close, and you should see the results.
Great. Yeah. Thank you very much. This is more or less what I expected to see, or what I hoped to see. It's just to give me an insight into your perception, and I'm very happy that your perception spreads so much. So there are different points of view on computing in school, as you now see, I hope. And this list of items of the questionnaire, it's not a random list. I selected it from a list of approaches that exist in computing education in Germany over the last decades. These approaches all reacted on the actual social demand at a certain point of time, and I would like to introduce them now to you a bit briefly. I think in other countries these approaches are more or less the same, so maybe you will recognize the one or the other, and maybe you have a different name for it. Okay, the first three approaches that are strictly or strongly related to computers and computer systems. The first is more or less the oldest one. It exists in German schools since 1960s, when first teachers began to teach some computer science in the higher secondary school for interested students. This approach is focusing on algorithms, and mostly they wrote some algorithms and small programs with pseudocode and with pen and paper. This was more or less a reaction from the social demand that the computers in working life got more and more in focus, but in schools they were much too expensive. So there was no chance that each student had a computer and so on. I think you can imagine. So if you want to bring up the topic of computer science in school in the 1960s or later, you had more or less to do it on pen and paper. So this was a reaction, focusing on the algorithms and do something that was handleable, that you could handle in class with your students to write some algorithms. There was nothing much more to do then. In the 80s, there existed some more. I just have a question. Ben, please, could you please mute your microphone?
Of course. Sorry about that.
I hear you writing on your keyboard, so okay. Thank you. And the second approach that arose in the 1980s, when more and more Office standard programs got into the classrooms, not the classrooms, but into working life, and so they more and more got into the classrooms as well. The first schools they had now these computers as well, and they was the task then to use the standard applications to solve problems and to judge whether afterwards the solution was correct and so on. So it also reacted on the time that we had new possibilities to use the standard application. The next approach on computing in Germany was also was strongly connected to computer systems. Starting from 1990s, it became more and more interesting to focus on how computer systems are designed, how computer systems interfere with people and society. So Johannes Magenheim and other colleagues created the approach on the system-oriented view on computer science in school, and there they suggested to have a look on existing computers, existing computer systems, existing software, and to deconstruct how these applications might be designed, to feel and to search for the design decisions, how computers, why a button is on the right side and not on the left side and stuff like that, why something is computed in this or that way, why a data field requires an integer and not a real number, and so on. So this was a new view on computers in school to bring the topic of the so-called social technical systems in school that have an effect on the society and on the people as well. And in this teaching approach, the students also are able or got able to create their own software, but not starting from scratch, but starting from an existing software system, deconstruct it, and think about how this could be developed a bit better and augmented and so on. So the next teaching approaches, very briefly, next teaching approach is not really an approach. It's more or less a framework to judge whether an idea should belong to computing at school or not. It was developed by Andreas Schwill, and it's called Fundamental Ideas. There you have different criteria why that has to be fulfilled by a certain topic, whether it should be part of school or not. The first criteria is the horizontal criteria, which means that a topic should be part of different areas of computer science, but also different areas of everyday life. If the concept is existing or can be found in different topics, in different other beings, then I somehow lost my own picture. Okay, let's see.
Hi, Ira, you should see it again. The poll just
yeah,
popped up.
yeah. Okay, that's right. Okay.
Okay.
So because I wanted to make to show something with my hand. So this is the horizontal criteria is to find computer science the regarded topic in different areas. The second criteria is the vertical criteria, which is if you can teach it into different intellectual stages. Can you teach it already at primary school or at secondary school or only at university? So this is one criteria as well. The next criteria is about the time. Schwill said that there should be more or less only such topics and concepts taught that have an effect that can be perceived in time. So we have to teach the stuff, or if we can only teach stuff, or we should only teach stuff that does not change so much. So that this includes that we should not teach only the latest products, but the long-lasting ideas. And there are different other criteria as well, like it should make sense to the students and stuff like that. So the next approach that was created by Norbert Breyer and Peter Hochwieser in 1994 and the year 2000. This approach is focusing on information, data, modeling, and processing. And there are a lot of time in this kind of approach is located into activities where students model and where students interpret some models and create and talk about the difference between data and information. And they also create several programs as well, but only in later years. This approach is implemented in a wide range in Bavaria, where they start in the 6th grade. And the newest approach is the context-oriented approach. They're starting from everyday life and to decontextualize the general principles of computing in the whole world, in the world we see. Like you see go outside and you have a phenomena that you cannot understand, let's say my video is not working or something like that, and then you can reflect on what's the point? Why is it not working? Why is my video not working? Why is something else not working? What could be the cause? And what is the principle behind? So this is the computer science in context very briefly. So these approaches are very briefly. So if we all know these different approaches and to see they all reacted on more or less the restrictions on the world, on what we had in school at a certain time. In the year 2000, if we go back to the information-oriented approach, there you might see a connection to the internet. This was when the internet came more or less into our lives. And in the year of 2008, this was when we all knew that computer science is effective. It's affecting our everyday life. I think some of us knew it before, but so this has something to do with the science as well. So, what's the right or what's the wrong approach? This is something that some of my students sometimes ask, and I think some of your questions from last week also addresses more or less this topic. And to give a more or less answer, I just make a small experiment at the moment, and therefore I switch my camera to another camera because I've prepared a small experiment. Okay, so please open your window to full screen if you want to see it a bit better. And now you can see the first thing that you can see is only a white page that is lying on the floor of my office at home. And now I hope this experiment works. Okay, this is a piece of I can show it to you. This is a light. I have a portable light with me. See it? Oh, you don't see it. Oh, okay. So this is what I'm doing, and I'm producing a shadow. And for yourself, you can post it in the chat, but you don't need to. You can try to guess what do I have in my hand. Have you any ideas? Think of what this might be in my hand and turning it in the light, and you can only see the shadow. So this is hopefully more or less what you can see or what you cannot see, because this is about what you cannot see. Well, with computer science, in school, it is more or less with this shadow, or this thing I have in my hand. You all, as a teacher, bring your own perspective into the classroom, and your students only see the shadow of your own point of view and from life. But your students never have a chance to really see what is producing the shadow, because computer science is not touchable. You cannot show it and then they will understand. You can only bring it to their life using such phenomena like the shadow or any other projection or stuff like that. You can also bring a phenomena that is caused by a certain topic into class, or you can also get your students to interact with the things you want to teach. And now I make cut off light. Okay, let's see if you see anything. Can you see something?
Yes, Ira, we can see it.
Okay.
We can see some lines on a piece of paper.
Yeah, and the lines, and so I will just show you what you, as a teacher for computer science, you cannot show, but I will show you. What I have in my hands is just two pieces of chalk. So this was to demonstrate you a bit the different perspectives on computer science. And for the last several minutes, I just would like to give you an insight how to cope with these different perspectives and how to make a bigger picture for your students out of it. So the questions on teaching computing that you always have to answer when you plan a lesson is why and for what are we teaching? The arguments for compulsory subjects, for instance, or for a certain topic, for example, more or less the analysis of the social demands. Another question is what to teach, the selection of topics and principles to be taught, a kind of, we call it elementarization and clarification of the science content. What is it? What is the structure of that, what I want to teach? What is the scientific background, including a choice of principles and also a suitable phenomena? What are the phenomena, the examples that can be used to bring that desired or the certain content and that certain principle to the student? And the other question is, how should we teach? What is a design and arrangement of computer science lessons? And as you may already guess, there cannot be a one and single right answer for that, because you always have to construct it again and again according to the other two questions. Who are your students? Who are you teaching? What perceptions bring they into your classroom? What are the presumptions that are expected? What is the student's view? So what do your students think about that? And last but not least, who is teaching? So what are your assumptions? What is the teacher's view? And the teacher's view in a certain topic is more or less never the same than the student's view. And for this, these questions can be arranged in a kind of framework that's called educational reconstruction for computing at school. It is just a framework, a kind of hint that you can use to check if that you have thought on all the different criteria, on all the different perspectives that you came along. So it does not matter where you start in this framework. You can start more or less. It's never a bad idea. It's always a good idea to start at the clarification of the social demand in the subject. There you can ask such questions: what is the educational significance? What can the students learn? Why should this topic be really part of school? Why is it part of general education? Why should every student learn about it? If you have answers to these questions, then you can go to the selection of computer science phenomena. There are 3 different kind of categories of these phenomena that you might consider. One is these phenomena that are directly connected to informatics systems or computer systems, like a laptop, a cell phone, everything that can be touched and seen and is perceived directly as a computer. The second is indirectly connected to computer science, like when you go into a supermarket and it makes beep, and a certain machine sums up all the prices of your shopping, then this is indirectly connected to computer systems, because most people don't realize that there are computers behind. And there's a third kind of phenomena that you might consider, these are not connected to computer systems, but also but are phenomena that are inherent for computer science, like different runtimes of sorting algorithms, for example. So these are only two parts of the framework, and the last are different perspectives as well. The first of the last ones are the clarification and of the science content, what is behind, what principles are behind, how detailed is it, do the students have to know to understand this kind of phenomena. And this is directly connected to the student's view, because what is in the scientific textbooks is not always the same than our students think. Students have their own perception what might be a cause of a certain phenomenon. They all have experience from everyday life with computer systems. And so it is really important to make kind of investigation of the student's perspective. What do your students think about the phenomena? What kind of concepts and models do they use to explain it? They might be not the same like the scientific view, but they also might apply until a certain point. So you should respect the point of view and the student's view as well, because there might be also correct in the one or the other way. Oh my! I think I have a problem with my slides. Last but not least, there's missing the investigation of teachers' perspectives as well. What do you, as a teacher, think about computer science in school? Why should it be taught at all? What do you like as a teacher for computer science? And also, what is your explanation for the phenomenon that you're teaching at the moment? All these thoughts about different perspectives on a certain topic of computer science result into your special design of an arrangement of computer science lessons and courses. So I hope this more a bit theoretical view can help you on the long run to plan your lessons and to sort out what your teaching should be about, or to sort out what you can leave out, and also to select interesting topics for your students. And with this I will pass back to Benjamin.
Okay, thank you very much, Ira, for that enlightening presentation. I think there's lots of very valuable elements in that last slide in particular, and some people have already been asking about if they could receive the presentation. Just as a side note, we are recording this webinar, so we will post the recording of this webinar on the course, so you can go over each of the different slides and what Ira has told us after we've done that posting on the course.
Yeah, and I will do.
Sorry, Ira.
Can you hear me? I will check the last slide. I think it's one slide is missing or something. I will check it, and then you will get the correct version.
Okay, great. So now we have about 10 minutes for questions from your side. Now we've already collected some questions, of course, prior to the webinar on the course, and there's quite a few there. I'm not sure if we can answer all of those, but I will flag up one or two. But if you do have any other questions, anything that you would like to ask Ira based on what she's been presenting tonight, do please post them in the chat. And then I will relay those to Ira to answer. So if you have any questions, please post them in the chat. While you do that, I'm going to pick up one or two questions that were posted on the actual course. And the first question there is a question I'm not really sure Ira or myself can answer. It's an interesting question, but a very difficult question. Why don't we have an agreement at European level for a great investment in all the countries about teaching programming? This was the question that received the most votes from all the participants, and it was asked by Pedro Francisco. So thanks a lot for that question. From my side, I can say I fully agree. It would be very nice if we would have that kind of European initiative. We can definitely see an increased interest from the European Commission in this topic, and some of you might have participated in the EU Code Week, which happened at the end of October, where there's lots of events around the topic of coding and computing in the classroom. And this is something that the Commission is really expanding. The fact that we are running this MOOC at the moment is also based on the increased interest from the Commission in the topic. It is partly funded by the Commission. So while we're not there, of course, in having an agreement at European level, I think we are seeing an increased amount of activities and fundings coming from the European Commission, so at the European level, on this topic. I don't know, Ira, if you have anything else to add there to this question?
Not really, but well, there's with educational issues, it's always the same. It's restricted more or less to the federal system. In Germany, we have a kind of funny saying that we have a hexadecimal educational system. This may point out that it is very difficult to change something in the educational system because we have 16 different counties, 16 different states that all can judge and create own laws about what is into school and what's not. So it's not an answer to your question, but it's more or less describing the problem.
Yes, absolutely. So let's have a look at another question, something slightly more practical from Thomas Linder Madsen, which also received quite a lot of votes. Ira, do you know of any good strategies that we can use to motivate teachers to take part in these kind of activities like the MOOC, or in teaching or engaging more with computing in the classroom, as long as it's not part of the curriculum? Thomas felt that it was very difficult to motivate teachers as long as there's no really state incentive in regards to the curriculum. Do you know of any specific strategies, or do you have any ideas how we could deal with this issue?
Well, just spread the word. Teachers, what teachers like are, and to participate in some inter-teacher trainings and other stuff that we recognize are two points. One point is that you get some kind of respect or notice that your activities are noticed by your principal or other instances of the administration, that somebody says, oh, well done, that you go there, kind of handshake or whatever, or kind of certificate. This is something that drives a teacher to take part in the in-service teacher training. And the other stuff, and the other point is a bit simpler. It's the community. Tell all other teachers how much fun it is to be part of this MOOC, to be part of the computer science community. Take them to meetings with other computer science teachers, and they will see how friendly, how much fun it is to be part of a new, a new small group that can decide and can have the opportunity to really change something. So I think this might be a driver for this as well.
Yes, I absolutely agree, Ira, there, and it's in a way something we are trying to achieve at at some level with this MOOC. First of all, creating a small sort of community by the participants of this MOOC. And then also, if you haven't yet heard about the eTwinning network, it's a network of teachers run by European SchoolNet, or sort of developed by the European Commission. If you don't know about that yet, make sure you Google it, eTwinning. I'll put it into the chat later on. And that's really a community of teachers where you can get together, find like-minded peers, and where people who might be a bit skeptical can slowly approach a topic by connecting with other teachers who are a bit more familiar with something. So, okay, great. There's a couple of questions now popping up in the chat. I have one more question from the actual course. So before I go back to the chat, let me just quickly come back to that. Ira, do you have a sense from your experience, maybe in Germany, how much time would you recommend, if you maybe talking to a policymaker, how much time would you recommend them to allocate to computing in the classroom? Maybe that's a difficult question to answer because it depends on the level, of course, of the school. But do you maybe have some general guidelines on how much time is necessary to teach computing in a class, in a school?
Yeah, sure, I have some recommendations. First recommendation is start early as you can. You can start with small activities in primary school, according all stuff that is, I think, all stuff that is around code.org, for example. You can also bring up some topics in the normal lessons. I think all you don't have to allocate in primary school a single subject, because in primary school I think all countries have many different systems on what kind of subjects you have, but you might have all a subject that regards the things out of in the everyday life. In Germany we call it Sachunterricht, which means education about the things. And there you're right, and there we can allocate a few hours each year to bring up this stuff that students like and students really want to know. And afterwards, in lower secondary school, I would recommend 1 or 2 hours each year and each week, because it's more or less like a language. You have to practice, you have to stay connected with it. You need a room where you can state questions. When you get 10, 12 years old, you begin to really ask very abstract questions, probably, and the students are very curious and they need time to fill their curiosity. So I would recommend a few hours each year in primary school, and 1 or 2 hours each year and each week in secondary school from the beginning of lower secondary school.
Okay, excellent. Thanks a lot, Ira. There's a couple of questions popping up now on the chat, so I'll just relay one or two to you. There's been a question by Yuko about the involvement of girls. However, yeah, I'd just like to flag up there that we are actually having another webinar next week where we address this topic specifically, and we'll have a guest speaker from the organization called Rails Girls, who have experience on this topic and will be sharing their expertise with you. So if this is a topic that interests you, and it is definitely something that's quite sort of significantly on the political agenda at the moment, then do please join us again next week. It's Thursday, the 27th of November, at the same time at 6:30. There was another quite interesting question I felt from, I'm sorry if I'm pronouncing this wrongly, but Mpia Sifiridou, and she sort of flags up that, and it's something maybe that's quite relevant in the context of the course. A lot of current strategies, a lot of tools, in a way, focus on engagement of students in the topic of computing. And as a result, they're quite games-oriented, quite sort of simple in their design. Is there a danger of sort of treating this subject a bit too trivial and to send out this message to students that this is all just about gaming. So she asks, do you know of any strategies that we have to motivate students to treat computer science as a demanding subject that isn't just only about gaming?
Oh, well, it's an interesting question because gaming and creating games is not the same. Gaming is an entry point, sure, because all students like to play, and it's very natural for kids to play because playing is the way they learn. So this is nothing that I would connotate with something that is not useful. So playing is very interesting, and playing is the kid's way to learn. So this is, if we have this in mind, I think we can use it as a tool, more or less, to not just to engage, but also to teach students the complexities on the one hand, and yeah, the easiness to create computer programs, how hard and easy it is at the same time to create a computer game, that you really have to think about the structure, that it's not so easy to plan a game, because what's a good game is not really easy. There are many, many games that are really lame in that, but the students are very proud of what they did, and they really like to share with other students because they did these games on their own. And so I think I really would like to stay using games as an entry point for computer science in school because it's natural to play.
Yes, absolutely. I mean, I think the elements that you've just mentioned there, we are actually also picking up on another MOOC we are currently running on the European Schoolnet Academy. Some of you might be participating, in fact, in that. It's called Games in Schools. Yeah, so if you are interested in that, do have a look at that course as well. It's led by Ollie Bray, a very experienced head teacher from Scotland. And he also picks up some ways how games can be used as a tool for teaching computing, and it is actually also a topic of the next module, of the upcoming module. So we will pick up some of those issues as well. So time for just one final question. There's quite a few other sort of comments still coming in, but I'll pick up this last question here because it links up to something that was also mentioned on the TriStarter in the course, and it's from Gracie Coco Di Mara. And she says it would be very interesting to find more ways to engage other teachers from other subjects in her school. It's something that we have tried to address in some elements already on the course and will continue to do so. How can we maybe create joint projects with other subjects? How can we show that this subject is not just purely technical, but it actually relates to art, to the sciences, etc., to geography. Ira, do you have any specific ideas on this? Are you aware of any projects that teachers have done together with teachers from other subjects?
I think there are several projects that can be done. Well, I myself have done a project together with teachers of, I don't know, really name playing theater art, because we did a kind of play about how the internet works and on safety and on how, let's say, not only the internet works, but also on copyright and how, what about on copying films and music and stuff like that. So we did a play that was presented to all students of the whole school, and they were forced to go there, and we were more or less forced to do the play, and it was great fun. But this is really difficult to arrange in general. Like this, I think this is an interesting point to point back to the framework of educational reconstruction. There you have a framework where you can find out what are the needs of the teachers, what are the needs of the students, and so on. And maybe you will find a phenomena or a kind of context where it is not only interesting to work together, but also useful for the students, because the content structure may overlap, or the phenomena may overlap, and stuff like that. But this is a very special thing, I think, to arrange in each school from class to another class, because you not only need a nice idea and a nice topic and so on, but you also need an interesting and willing colleague to do this. So, there is no silver bullet.
Absolutely, yes. So I think we're doing our best here with everyone here on the course, and trying to make sure that there's more excited colleagues that we can share expertise with and maybe do joint projects on. So I think we'll leave it at that. There's lots of comments also still coming into the chat, answers to some of these questions from your side. As I've already mentioned, we are recording this webinar, and we will post the recording on the course. So you can have a look again at the presentation and any comments made in the chat. A big thank you to all of you for having joined us. We were 47, in between we're now 45, so we did grow still a bit. And do remember, next week we have our next live webinar on the topic of how to engage more girls into this topic of computing in our classrooms. I'm just seeing that Tira has reminded me of the link to the eTwinning network, so I'm just going to post this into the chat now. Here you go, eTwinning.net. Make sure to check it out if you're not aware of this yet. It's a fantastic network, and it links also into elements of what we do on the European SchoolNet Academy. So finally, a huge thank you to Ira for joining us, for taking the time to join us, and for presenting your experience and your expertise on this topic. Yes, that's